Welcome back to another episode of MS3 Is Talkin Nerdy, the show where we're diving into the weeds for technology and modern capabilities. And today we're going to be talking to you about a little project called Tavros. I am Aaron Weichel, your host, and with me today is the project leaders, Jose Montoya and Randy McCright. And they're going to give us all the little nitty-gritty details about Tavros, why it's important, and why it's really starting to pick up a lot of steam. How are you fellas doing today?
Doing pretty good, thanks, Aaron.
Yeah, it's a good day so far.
Awesome. So most of you have already met Jose from our previous podcast, Industry of Animals. So welcome back, Jose. Anything exciting happened since the past couple of weeks since our last podcast?
I don't know. So I'm in South Texas, so I don't know if this happened before or after, but around that time we had this huge deal with like 6 inches of snow and like the whole state shut down. So that was a fun time.
Awesome. Yeah. And I see you survived. You still have power in the house, so that's great. Welcome to the first time, Randy McCright. So Randy McCright is one of our team leads here at MS3. He's been working quite a bit on Tavros and really driving a bunch of modern technologies out there. Randy, give our listeners a little background on who you are and some of your history.
I'm a bit of I've done a variety of development over the last 6 or 7 years, kind of from embedded development to UI, a little bit of UI development, but the last couple of years really focusing on the API space, API enablement, and API development in general, and just focusing on that in terms of career-wise. And I guess externally, outside of work, rock climber by trade, into music and those types of things. So, try to keep variety.
Yeah. He's you used to do guided rock climbs or something like that, right? Or was it guided whitewater rafting?
I did whitewater rafting through college, and that's like a little bit of an extra hobby. I don't do it too much anymore, just once or twice a year. But I did some climbing coaching, on weekends and evenings and stuff for a while, which is a lot of fun. Before the whole pandemic stuff.
Awesome. So true story, Jose. Randy, through college was guiding whitewater rafting, but Randy doesn't know how to swim. So go figure.
Well, I guess that's a good reason to do everything right, but not fall in the water.
No, I'm joking. For sure, he probably knows how to swim. So, anyways, thanks everybody for tuning in again. So again, today's topic is we're going to talk about Tavros. So a little bit of background. So Tavros is a project that MS3 birthed through a variety of different demands and influences within the market. What we've noticed over the past decade or so is that organizations are building integrations and APIs that don't support their business, they don't support their operations team, and they're very fragile. In addition, they're very locked into a product, or they're very, non-extensible by nature, and they're not really given the flexibility that organizations need to be cloud native and cloud ready. So because of that, Jose and I had been talking about a project, for probably at least 3 years, right, Jose? 3 or 4 years around API management or, some sort of open source. And, a couple pieces fell into place in order to bring Tavros to the market, right? The really big missing key was the DataSonnet component, which is the data transformation. As many of you know from some of our previous podcasts and blog posts, is that DataSonnet is a very powerful transformation language that the MS3 team has really extended on and built enormous amounts of capability for data transformation. And that was the missing key to bring the Tavros project to life. And so Jose and myself and Randy, we had some discussions and really dove in about a year ago. Tavros came from just an idea and thought process into what it is today with our V1 release here looming. Again, it is open source, so V1 release just means this is a stable, functional release with all the capabilities that we want to have in it, and then we'll start on to the next iteration. So enough of me talking. Jose, I want to pass the baton over to you. Why don't you give sort of your thought and vision and idea and the evolution of that for Tavros, to our listeners, so that way that they can, get from your perspective what some of your main drivers were.
Yeah, so I think the most basic conception of Tavros was just, can we build an open source, flexible alternative to all of the big iron offerings, right? To the Anypoints, to the Oracles, to all these things. Again, that is open source, so that is low cost, but it is also flexible enough for you to pick and choose your pieces, right? If you go with Anypoint, you're stuck into this and this component. If you go with Oracle, you have that and the other. So that was kind of the basic proposition. As you said, DataSonnet was kind of like the unlocking step, the unlocking key that kind of allowed us to commit to the product, addressing data transformation. But I think some of the other really important ones were around observability, right? Because as microservices have become kind of the standard across the industry in the last, 3-5 years maybe, observability is something that every company has had to address, and we find ourselves implementing observability tools in MuleSoft, in Spring, and it just felt like we were solving the same problem again and again with tools that didn't really lend themselves to this kind of solution. Eventually, we found the Open Tracing project that is based on the distributed tracing paper by Google. Mm-hmm. We tied that into the platform with DataSonnet, and from there the ball just started kind of rolling from there. Everything started falling into place.
Yeah, that's some really good points there. Solving those problems time and time again with platforms that really don't lend themselves, to supporting that type of capability has been a pain point for not just us but companies around the globe. So Randy, a lot of these components that we have as part of the Tavros stack are CNCF, either sandbox, incubation, or graduates, including Kubernetes. Talk to me about the power of what Kubernetes brings to the platform, and why is it so important to be cloud native out the get-go?
I think one of the reasons it's so important is, for one, it's being widely adopted. We've seen it in a lot of places. Almost every client we interact with is working directly with Kubernetes in one way or another, whether maybe they have multiple environments. Some are Docker, some are Kubernetes, some might be behind the scenes containerization, like what MuleSoft has on Cloud Hub, right? And so I think it's just becoming very popular, and it allows developers from a lot of organizations to be able to work towards the same type of format for configuration and standards. So it's easy to kind of adopt and change and move the overall field forward. And I think what Kubernetes really allows is that standardization for all sorts of different ways of deploying things, from Helm charts to operators to just standard CRDs for custom resource definitions for basic things. It gives you kind of an expected way to view and configure all of these pieces, and so that makes things like GitOps way easier, for example.
Yeah. So those are great points, right? Helm and GitOps. One of the tools that we've fallen in love with, as part of this, Tavros stack is Flux CD, right? So throwing it back over to you, Randy, tell us about the value add that Flux brings to the table.
Huge value add in terms of having a history of the changes that you're making to your overall system. So basically, Flux is an operator that's going to run in your Kubernetes environment, and you can point it to a variety of Git repositories, for example, Helm repositories, etc., and provide it with more or less standard Kubernetes CRDs that are going to tell it how to deploy, how to manage, how to update, and what to deploy for all of these various components. And you can organize your repositories and how you do this in a variety of ways, have multiple repos, multiple security levels, depending on what it is. And so you can have a lot of fine-grained control over who can modify all these pieces and a regular standard Git history of those changes. And then it protects you from manual interventions and accidents and things that can happen manually within the cluster. You can basically leverage that to restore your state back to your goal or your state.
Yeah, that's really powerful. And we know that this is something that the industry really needs, because that configuration management component is something that you see in Chef and Puppet in order to provision VMs, right? So that way people aren't going in and changing, SSH access rules within a VM. When Chef and Puppet see that, they will revert that back to what it originally was. And, so that type of capability definitely is something that is needed within the enterprises from just a IA perspective alone. So definitely powerful there. So some other products that we have that are graduates from CNCF, Jose, is things like Jaeger and open tracing and open telemetry. And you touched on this, as part of the vision, addressing these problems that we're having to face time and time again with observability. So walk us through how that these standards and these CNCF products are really enriching the platform.
Okay, so I guess a quick introduction to the observability stack. So we use Jaeger for tracing, and we use Elastic for log aggregation and metrics. So these three things kind of compose what an observability stack needs to be for microservices, right? You have metrics where you have things like how many API calls, how many messages are going through my particular integration flows, how many errors, things like that. Traces address kind of a trace right through your API stack, through your integration stack, from your gateway all the way down to your process layers, all the way down to your backend systems. And log aggregation is just basically collecting the logs from different independent applications in a microservices style, and then putting them all together in the right order, right? So the logs from the gateway are correlated to the logs from the backend, and you can see kind of in a unified way all the logs that were printed out from your application. So with these three things addressed, it just makes troubleshooting, root cause analysis, anomaly detection, or you have a bottleneck and you need to identify where it's happening. It just makes ability into your platform easy, which microservices kind of prevent or is one of the challenges that it brings.
Yeah.
Go ahead.
Yeah, no, as I said, that's really, really important, right? Being able to see where those bottlenecks are, because as enterprises, we're constantly trying to identify how can we eke out just a little bit more performance because we have more users consuming, assets and resources. So the more performance that we can provide, the less hardware and infrastructure that we have to buy. So being able to see that is very powerful.
Yeah, and so what we've done is we basically chose a couple of tools that we would, make shine. Basically, we would pick Elastic and Jaeger, and we would pick Camel and the open tracing framework, soon to be completely, I think, taken by the open telemetry framework, right? And basically we said, okay, we're going to make these components just so seamlessly integrated that a developer shouldn't have to worry about the logs that they got to place, the tracing that they got to place, the bringing of the dependency, hooking it up to the collector and the agent and all that stuff. So the idea is that a developer should just write their application and automatically would have logging, tracing, and metrics into these Jaeger and Elastic components for free, basically. So you'd be able to see between your Camel applications and our service mesh with Kuma that could, enhance some of these traces and actually give the ability of do tracing outside of Camel, into any other framework. But basically, we provide that solution for free, or at least that's the intention.
Yeah. So how many times is it that you went into a client's code base and they're having a problem, and so you go to the logs and it's just empty because the developer that built the application put no logging in there. So it's fantastic that we're having that built in from day one, because that's definitely a problem we run into.
I think it's either extreme. It's either no logs or just logging everything, where it's like I can't tell what's important. I don't know where the issue is because we're logging every single step of every single integration. So yeah, it can be difficult.
Feast or famine, right? So, all right. So you touched on a couple things, right? So we have some core components in there, and before we dive into the core components, one of the things, and Randy, maybe you can talk a little bit about this, is that we've adopted the Jenkins for pipelining and build out, and the way that we do this is we have a standardized CI/CD pipeline for the build, test, and deployment for everything that we build, based on some of our archetypes, and we'll get into those in just a minute. So Randy, talk to me a little bit about the importance of having a repeatable pipeline for deployment that is in addition to what we already had discussed a little bit with the Flux CD stuff.
Sure, yeah. So Flux only takes care of one piece of the puzzle, right? It's really talking about the infrastructure in terms of your deployed applications, right? You still have to think about your actual code bases, building those, generating your images, putting them somewhere, and then making the commits to the various repos to facilitate Flux, for example. So I think having a repeatable process for that is super key to create a clean developer experience, right? So that we can actually go through, dev, test, staging, into prod, and not have to have, manual builds, manual, changes. Some clients we look at and they're doing, manual emails to trigger things, and, it's still that clunky process where you can make a lot of mistakes. So having that repeatable CI/CD process for every step and kind of working in tandem with what Flux does for GitOpsing the infrastructure, it creates a very repeatable process. And we leverage actually Helm as well on top of that to make even pipelines simpler. A lot of the platform already uses Helm in terms of deploying to the Flux repositories. Part of the process for our pipelines for the Camel applications, for example, is building out the variables for our Camel-based Helm charts, right?
Yeah.
It makes it all a lot more easier to template and have this nice, clean process every time.
Yeah, repeatability is something that, I can't tell you, probably 90% of all of our customers that we work with, we're helping them to build out and define what their DevOps is, because there's so many organizations out there. Whenever you talk to them about DevOps, they're like, yeah, we have DevOps. And what it is a sysadmin who is going in and running a Maven command to build an artifact, and then manually going through and deploying it, and then manually going through and running, some test cases that came from the testing team. And it's like,
we have DevOps. His name is Steve.
Yeah.
And that's like an automated process. They submits a Jira ticket for the guy.
Yeah. It's crazy. So definitely helping to have that DevOps from day one, so that way organizations are ahead of the curve is very powerful. So Jose, I've talked about DataSonnet, Camel. Tell us about why those are key to the Tavros stack.
Camel and DataSonnet. Okay, so this is probably one of the earlier conversations that we had, before Tavros, even as a project name came around, right before we actually committed to building a product, was because the platform is supposed to be an enterprise integration platform, right? Integration is what we aim to address. So what integration framework, what integration tool do we choose?
Right.
The platform can support any framework, really. You can use MuleSoft or Camel or Paca or I don't know, anything else really. A regular Spring Boot application, it'll work. But we needed one, like I said earlier, that we could make shine and we could seamlessly integrate into the other components. And Camel just felt like the obvious choice. I mean, we did look at a lot. We did some studying into different components, but at the end of the day, Camel being open source, having a large community with not a really big entry barrier. Like I've gotten a few different things contributed into the Camel project, and it's been a breeze. I've tried contributing to other projects like Spring Boot or Mule itself, really, and it hasn't been as seamless or as pleasant, really, because a contributor or the maintainer himself will reach out to you and say, hey, can you tweak this? Can you change that to this other way? Or in this project, our convention is to do X instead of Y, things like that. But I think a big point is the community, right? Because of that low entry barrier, you really get the latest and greatest while still being in a mature framework, in a mature engine.
Yeah.
So that was kind of, I think, one of the big driving forces behind Camel.
Yeah. So and that's good. And we recently had some PRs that were introduced into the long-term support version of Camel, which pulls in DataSonnet. So talk to me about the evolution of DataSonnet. What is the point of it, right? Because one of the things that a lot of listeners may be thinking is, well, I can do my own Camel and I can do X, Y, or Z with it, but what is this DataSonnet? How does it really fit into the grand scheme of a, complete enterprise integration platform that provides all the, bells and whistles?
So data transformation, I think, is probably the heart and soul of enterprise integration, because the whole idea is that you have independently developed systems that you want them to talk to each other in some way. So you have to transform from the ubiquitous language of one to the other, right, to talk some domain-driven design. So you have to address transformation, because that's kind of the whole point of integration, right? At the point that we started talking about Tavros as a project, we felt like DataWeave is probably the only or the best, I suppose, language to address this. It was performant. It was pretty feature rich. It has a lot of functions that really address most of the needs for transforming data. Mm-hmm. But the problem was that it's not open source, so it was not something that we could just plug in and bring it to Camel and offer it to our customers. So DataSonnet comes from originally it's a Google project that I think it's built around configuration management, and I think it's mainly directed at doing things around Kubernetes, I think. I know that at least when Databricks, a company that re-implemented JSonnet, which is a Google project, I'm sorry. So Databricks re-implemented JSonnet in Scala. And I know their use case was entirely about managing Kubernetes resource, YAML files, basically. They found that the original implementation, which I think was in Python, was just not performant enough, but they wanted the power that JSonnet language had. So they re-implemented it in Scala. It's a great project. Like I've tried to go through the source, and it's just really, really crazy engineering what goes into parsing syntax and evaluating expressions and all this stuff. It's really cool. But so the point comes that when they deliver SJSonnet, it allows Modusbox, which is another company and is a partner of ours, to kind of take SJSonnet and make it flexible in a way that it can support not only JSON files, but XML and CSV. So at this point, it becomes kind of a core and flexible product that we then started to contribute to and added all the functions and a lot of other bells and whistles that we needed in the product for it to become what we needed it to be to address data transformation in Camel.
Yeah, that's good historical story there. I believe we contributed something like 300 plus commits to the DataSonnet project, and really have it to what's the release number today?
I think we're at 2.1 something.
Yeah, so there's all the capabilities that you can find in any of these transformation languages that are out there, and then some, right? So it's really powerful, and that's, as you mentioned, it really is the heart and soul of any data transformation. So now let's move into the next component, right? How do we get data into and traverse across the cluster. And Randy, being our resident expert in this piece, the Tavros utilizes Kong as its ingress controller and API management and the service meshing through the cluster. Walk us through, all the value add that Kong brings to the table with providing a service connected platform within Tavros.
Yeah, so there's really two main components that you brushed over there real quick. There is Kong, the gateway, and Kong Mesh, which is the service mesh, which is a fairly new concept. A lot of people are going to be more familiar with gateways, something like Nginx, than a service mesh, even though they've been around a couple of years. It's just now starting to gain popularity. But those two things together really do create that entire connectivity piece. And really the key, what I see that really gain you get from having that is your ability to abstract away a lot of concerns from the services themselves. You can extract away security from them in terms of authentication. You can extract away TLS from them. You can add in a lot of concerns of canary release and blue-green deployments because what you basically have is your Kong gateway, which you can structure in any kind of fashion you want to do, complex routing and manage different clusters, manage, different namespaces within the same cluster, communicate to other types of infrastructure besides Kubernetes and connect them all in via that way for routing. And then you have the service mesh, which is a sidecar pattern, which basically in Kubernetes, you have your containers and you can, attach a secondary container to them to basically intercept and proxy on a small scale, it's inbound and outbound traffic to apply, various policies. So one of the great features that comes out of the box with that is mutual TLS, and it gives the ability to encrypt all of your traffic without having to worry about that at all for your services. All of your services can be plain HTTP, and you can out of the box get high level security. Same thing with the tracing. We talked about how important that observability layer is, with Jaeger. And previously, and we do it with Camel to add an extra level of tracing. And we actually import, tracing libraries into our Camel applications by default for new projects. So it's there out of the box. But other framework stacks like Spring, Java, Python, etc., you'd have to, normally update these one by one to, give them, logging capabilities to log out to your Kibana or your Grafana, etc. Same thing with the tracing. You'd have to update each one to reach out to your Jaeger. But one of the capabilities of service mesh is you can just dynamically, any container that comes into the system, apply that tracing to it and apply that log aggregation to it. And it makes it a lot easier to make everything in your entire system uniform.
Yeah, and that's, I keep hearing a recurring theme here from both you and Jose is, out of the box. It does it for you out of the box, tracing out of the box, observability out of the box, right? So Randy, dive a little bit further into that about, other capabilities and features that Kong brings to the table also that's out of the box, maybe in the security and plugin, realm for API enablement.
So so before I even get kind of fully into the security, I guess a huge piece of what you want in kind of an enterprise integration platform, one of the major pieces that any point platform gives is exchange, right? It's a way for you to just disseminate and share your specifications, what your API is supposed to do, and kind of regulate access. Apogee's got the same type of concepts as well. And so Kong brings that kind of to the table out of the box for you and integrates directly into the various security plugins, for example. And so it gives you a lot of ways that you can approach the security. You don't even need to leverage the portal if you don't want. But basically, if you can host all your specs, grant different teams access for sharing and consuming their specs, they can create API keys, all those types of things, and self-service in a lot of ways. Security access, depending on your organization's rules, and this is all very configurable to meet the demands from one client to another. Even with we have a base opinionated view of how to deploy and utilize Kong and Tavros, but even with that base, there's still like a high level of customability there, and so there's quite a few plugins. There's a variety of security plugins, from whitelisting to JWT tokens, full OAuth support, OIDC support, basic auth credentials, and you can apply these in a variety of ways for individual consumers or blanketly across all sorts of applications. And then if those aren't enough, really, they have a really simplistic Lua plugin framework to extend and modify plugins and create all your custom needs that you have for your organization as well.
So what you're telling me is that all the listeners out there, their kids that are building custom plugins for their Roblox games can now build some plugins for them for their platform on Tavros.
Exactly.
Yeah, fantastic. No, that's a lot of good information there. From my perspective, Kong is really a really strong add here because, again, right, the Kuma component is one of those CNCF projects, and the way that Kong and Kuma work together in order to bring that connected platform is really powerful. You don't have to worry about different configurations, different ways of different products. You can utilize Helm charts and have them linked together to deploy your root and your ingress and have that propagate down into your services in your service mesh, so that way that it's not a multi-step deployment process. It's all in one nice seamless way, and that brings me to the next step that I really like about Kong Mesh is the ability to move over into VMs, right? One of the patterns that we see, especially with organizations, is they have legacy stuff, right? And as much as people like to talk about it, forklift moves just really aren't conducive to a good business strategy. So what we generally see is a strangler or a iterative process to migrate things off of one platform onto another. But one of the big value adds that we see with Kong Mesh is the ability to have it tie into a VM. So your legacy applications can now start to participate in that observability, in that mutual TLS, in that distributed tracing. So that way that you can tie in your legacy systems into your modern, and it's not really here and there perspective. It can start to work together in a fluid manner, and that's something that's super exciting. I did notice that there was an announcement that some really big key features coming out with Kong Mesh. One of them is the implementation of OPA as a first-class citizen. Curious if either one of you have had to taken a chance to look into OPA and see how that CNCF project could potentially participate in a Tavros environment.
I don't have a whole lot of experience with Open Policy Agent. I do generally understand its objectives and what the value will be. And it's basically governance, right? You want to standardize multiple things between plugins to API specifications. So I think the very first thing that comes to mind for me, and I think that what I'll dive into is bringing OPA policies into, for example, standardizing open API definitions, right? So as an organization, you don't want, if you have, a fleet of developers, a developer force, to all of them implement their APIs in their own way, So they all choose their own methods, their own return status codes, and some of them will be one way, some of them will be the other. So there's no cohesiveness. If another developer comes in, they basically have to know the idiosyncrasies of each individual application. Whereas with Open Policy Agent, you can say things are going to be this way for all APIs, still leave some room for implementation details or whatnot, but kind of bring the uniformity that, is valuable for an organization.
That's really good. That's really good. All right. We're getting close to time. So I just wanted to, ask Jose and Randy, each one of you independently, any additional key features or functions that, we haven't talked about today about Tavros and what Tavros brings to the table. I know that there's a lot, there's areas that we didn't touch with built-in single sign-on and, things of that nature. But, for the listeners for today that may be interested in hearing more, what are some of the really powerful features that Tavros, has today that maybe we didn't address?
So I don't think we talked about every single component, right. But I think, so we have for artifact management, we have Nexus Repository Manager. Like we said, Elastic and Jaeger for observability. I think those two, kind of composing our single pane of glass for observability is a huge value for companies. You don't have to go to 4, 5, 10 different systems to see logs and traces. You can just go to the one component and you'll see everything. And that kind of translates the same when you think about our GitOps of the platform with Flux and sealed secrets and Jenkins. Basically, you can see your infrastructure, your platform, and your application workloads in the exact same way. It's just a few Git repositories that have all this information spread out. So it becomes really easy to know the state of things as is. You don't have to go, again, to 5, 10 different systems. If you're deploying your applications to a different platform, that wouldn't exist in Tavros because everything is kind of uniform by design.
Gotcha. Randy, anything you want to add there?
I would just say, you kind of briefly mentioned on it, is Keycloak is huge. It's very integral to the system. It gives us a nice way to standardize, authentication and access to everything that comes into the system. And we definitely highlighted on it, but didn't come out outright and say it. But I think a huge key point of the Tavros system is that all of these things self-install, and all of the interconnectivity that you need to kind of go through and learn about for each of these pieces, we can basically take care of through our templating engine that we have with Ansible. So I think that basically that ability to link these pieces together and install them without you needing to do these pieces manually is kind of a key function there.
And that's a super powerful point that we did not even touch on is the fact.
Talk about.
Yeah, the fact that it is self-installing, right? You give it, a couple information in a manifest file and you kick this bad boy off, and 45 minutes later, you have a complete composite enterprise integration platform. Okay, so last question. So now that we have, a lot of customers who are test driving the platform, other customers who have already started onboarding and moving into production, what's the future of Tavros look like? What are some of the key features that are thought about, for enhancements that, our listeners and our future customers can expect and anticipate coming down the pipeline?
I think we want to extend our delivery pipeline to include things like SonarQube for static code analysis. We want to include things like Wiremock server, for example, so we can ease a developer's testing infrastructure to ease or streamline their testing processes and integrate that again into our delivery pipelines. The other one is Vault. We want to bring in Vault into the platform so we can manage secrets. They're maybe a little bit more sensitive than some of the other Kubernetes native secrets. And from then on, just kind of continue to build its flexibility so that clients that already have maybe a Datadog license or a Splunk license and don't want to use Elastic, they have the ability to kind of pick and choose the component they want. Or maybe they just like Okta and don't want to use Keycloak. So we want to rely on these established protocols like OAuth or Open Tracing or basically any standardized protocol to make the platform as plug and play as we can while offering the same amount of value that the core platform already has.
Nice. That's powerful. That's very powerful. Randy, what about you? Any thoughts, ideas for the future of Tavros?
I definitely think the open API, open policy agent that we talked about, especially with its integration into Kong Mesh, is a huge one to really consider because they bring in policy configurations for a huge variety of concerns, from how your CI/CD processes are working to control over what can be deployed into your Kubernetes cluster, right? So you could use OPA as an extra layer of security and regulation in your cluster on top of Flux. So those, and then I think it'd be nice. I envision having a nice graphical UI for the configuration for the clusters. And right now we basically have a seed values YAML file to create our configuration and build out the rest of the templating that's used to deploy. I envision kind of a more graphical UI wizard, like we've talked about in the past. I think would be a nice post V1 piece.
All right, cool. Sounds like a lot of exciting things that are coming down the pipe. I'm excited to see them come to fruition. So I guess we talked about a lot of things. What we'll do is we'll make sure that for our viewers and our listeners that they'll have the ability to have links in underneath of the video. So we'll get links out for Tavros, so that way that you can see the platform. Get links out to a lot of the CNCF, DataSonnet as well. Any questions, don't hesitate to reach out to us. Tavros has got a lot of momentum, a lot of support from a variety of different product vendors as well. So we're excited to be a part of this open source initiative. With that, I am going to call this a wrap. We'll probably need to have another Tavros call at some point at part 2, because there's so much value that we just missed out on.
Yeah, we could go so much deeper on each component and the difficulties of integrating them and learning the APIs of all of them. But yeah, not enough time.
Not enough time. All right. Well, thank everybody for watching or listening to MS3 Is Talkin Nerdy. This is Aaron Weichel signing off with Randy McCright and Jose Montoya. Thank you all. Have a great evening.